Hi, in the last video we finished discussing the basic definitions of the features of ellipses, and we talked about some of their characteristics and the standard and non-standard ellipse differences. Now we're going to talk about some specific mathematical relations about ellipses, and we're going to talk, and later on, we'll see how those relations help us solve problems involving ellipses. I want to first talk about this relation. B squared equals a squared times 1 minus e squared. You'll remember from the last video we talked about the standard equation of the ellipse. We talked about what it means, and we talked about how it changes when you're talking about non-standard ellipses. Now, we're going to ignore that for just a second, and we're going to concentrate on these mathematical relations. No matter what ellipse you look at, this relationship will always hold true. B squared will always be a squared times 1 minus e squared. Now pay very close attention to what I'm about to say. B is not necessarily half the length of the vertical axis. B in this case, in this relation, always refers to half the length of the minor axis. So in the case of the standard ellipse, yes, B would refer to half the length of the vertical axis because that's the minor axis. However, if you're looking at a non-standard ellipse where the vertical axis is the major axis, then B would be half the length of the horizontal axis, because obviously the horizontal axis would be the minor axis. And as you can guess, A in this relation refers to half the length of the major axis, not necessarily half the length of the horizontal axis, as the equation may suggest. It refers to half the length of whatever axis is the major one. In the case of the standard ellipse, A would refer to half the length of the horizontal axis, but in the case of such a non-standard ellipse as this one, where the vertical axis is the major one, A would refer to half the length of the vertical axis. A and B don't refer to horizontal or vertical axes specifically, they refer to major and minor axes specifically. That's one thing you have to remember. The equation and these relations, when you look at them together, they might give you the wrong impression. But bear in mind, in the equation, A refers to half the length of the horizontal axis, and B refers to half the length of the vertical axis. But in this relation, A and B don't necessarily refer to horizontal or vertical axes. They refer specifically to minor and major axes. And just to finish off this equation here, this relation, E refers to eccentricity. We discussed eccentricity in the last video. This is a useful relation, and we'll discuss why in just a moment. This equation now, as you can imagine, if we have two of these three letters, we can surely find the third. If we have the major and minor axes lengths, we can find the eccentricity. If we have the eccentricity and one of the axes lengths, we can find the other axes lengths. As you can imagine, it would require some simple algebraic manipulation to find them. So this is quite a useful tool when it comes to trying to find axes lengths or eccentricity. Alright, now we'll finish with that relation, and we'll apply it in problems later on in the next video. The next relation I want to talk about, foci coordinates. Now, we talked about foci in the last video and how they are equidistant from the center of the ellipse. But we didn't talk about how do we find the coordinates of the focus. Here's how. The foci, or the focus of any ellipse, will always be A times E units away from the vertex, okay? Let's just write that down for ourselves. Pardon my handwriting. And again, A does not necessarily refer to half of the horizontal axis length. A is half the length of the major axis. Just like in the previous relation we discussed, A does not refer to horizontal or vertical axis. It refers to the major axis, whichever one is the major. Alright, so if we ever want to find the coordinates of the focus, we always know that they lie A times E units away from the vertex, where E refers to eccentricity. So if we know what the center is, and if we know that the major axis is horizontal, then we know there will be a focus AE units this way on either side, on this side of the center, and there will be another focus AE units on this side of the center. There will be two foci that are equidistant from the center, and there will be AE units away from the center. In the case of a non-standard ellipse, where the vertical axis may be the major axis, this distance here, this vertical distance between the center and the foci, would be A times E. Alright, so the basic concept is quite simple. Whenever you have a center, and if you know which axis is the major axis, all you have to do is travel AE units either side of the center on the major axis, and you will find the two foci. Alright, that takes care of the foci coordinates part of this relation. And finally, on to the directrix equations. We talked about the directrices in the last video, and how they are equidistant from the center. Now, we don't, well, my group wasn't faced with very many problems as regards to directrix equations, but as you know from Dr. Cox's handout, that the standard sort of equation for any ellipse is x is equal to a over e, and x is equal to minus a over e, where a again refers to the half the major axis length, and e refers to eccentricity. It lies a over e units away from the center. If you were talking about something like this, where the major axis was the vertical axis, then obviously you wouldn't have vertical directrices, you would have horizontal directrices. And so you would have a directrix such as y equals a over e, again where a refers to the half the major axis length. Alright, so directrices will always be a divided by e units away from the center on either side of it, in the exterior of the ellipse. Okay, that takes care of these three relations, these three important mathematical relations. Now in the next video we'll be putting these relations and the concepts we studied in the previous video, and we'll be applying them to problems. Okay. Thank you for listening.